Those of you who did further maths would have covered this already. And in a way, those of us who just did normal maths have done. Do you remember how when we were doing the calculus, if you had displacement formulae, you could go and differentiate that to get velocity, and then you could differentiate the velocity equation to go and get acceleration. So you were differentiating twice. Well, that's all we're going to be looking at today. This 12.8 second order derivatives is all we'll be doing. I did it with my fifth form further maths kids yesterday, so it depends on those of you how far you got with the further maths syllabus before lockdown. But anyway, it's ever so straightforward. So just look at the little example. If we've got y being 5x cubed, then as you know, if you differentiate that, we call it dy dx. So multiplied by the current power, reduce the power by 1. Now, if you then differentiate again, have a look at the way it's written. I don't know why it is, but this is how you've got it written. You do d squared y, but over dx squared. So that's just how you represent the fact that it's been differentiated the second time. And obviously differentiating 15x squared, we get 30x. Now, alternative notation, if you go and look over on the right-hand side, if you well, actually I can't see where it is. If you differentiate, if we just called it f of x equals 5x cubed, okay, then as you know, differentiating it, you write f dash x, and that would be your 15x squared. And then if you're using this notation, you would call it f double dash x for the second differential to give you your 30x. Okay, so just like it says in that bit that I'm just fluorescent penning now, d2y dx squared is the same thing as f double dash x. Okay, so that's all we're going to be practicing. I was caught between two things, whether we tried to do more than just this little exercise this lesson, but I think on balance we'll just keep it simple. We'll just keep it to just this exercise today. So if you do happen to finish this, feel free to catch up with any other maths you've got, then we'll move on next lesson. Okay, but I thought there was enough good practice of indices to warrant us spending the whole lesson on it. So again, we'll just really quickly rattle through the two examples. So obviously, if you've got that one at the top, example 14, I think you've moved on to the page now. Yes, you have. So obviously, step one, get ready to differentiate. So take the x squared upstairs. That's the bit that I'm just fluorescent penning in yellow any second. All right, so you get ready to differentiate. And then dy dx, you differentiate that once. And then d2y dx squared, you do it a second time. And you can see example 15 again, get ready to differentiate. That's often the hardest bit. The fluorescent pen coming through at the bottom in a second. And then just differentiate once and then differentiate twice. Gosh, there's quite a lag at the moment, isn't it? You can't see that fluorescent pen yet. It will come through in a minute, I promise. Very slow. Anyway, I think you can all see where we're going. So what I would like you to do, please, is just to work your way through exercise 12H. I will do the same. I will stop the recording now. So once I've stopped the recording, please feel free to unmute with any questions, and feel free to put your cameras on if you want to. I think it's quite nice just having the cameras on at the bottom, so you can just look up and see everybody